Hello and welcome to the second and final presentation of our project. Today we're going to talk about our main achievements and results of our studies in detail. So let's start. Today's agenda is as follows. Starting with an introduction, UML-Diagrams and program architecture. We'll move to the methods and algorithm used to develop a solution and interpretation of results. So first things first. The main purpose of our study is to get a little closer to developing systems that will help companies in creating movie based on art book. We can do so by submitting the data to a machine learning model to identify specific trends and patterns, and then transfer everything back to the script. So one of the most important part of our research is to create accurate UML diagrams. So we decided to display this use case diagram. Here it is. Year diagram, sequence diagram, and the last one is dynamic and component diagram. So yes, thanks. And moving to the methods and algorithm, we wanted to offer an all-new method of turning the text of the book into a full and ready-to-be-used screenplay. To achieve what is wanted, a convolutional network has been designed. So, our program's architecture consists of 6 main parts: uploading and cleansing data, feature engineering, resulting in being effectively used for sentimental analysis, and algorithm of TF-IDF to tell the relative importance of each one. Only then the neural network is implemented and tested. And now I'm pleased to welcome Danylo, who will tell more about this.
To begin with, it is worth describing our neural network model and talking about the quality of the results. This is a model determined by inputs and outputs. AutoModel combines hypermodel and a tuner to configure hypermodel. The user can use it in a similar way to the Keras model, as it also has fit and predict methods. In this case, AutoCase creates 2 submodels, one for each piece of input. It has chosen the deep residual network architecture, ResNet 50, that we have already introduced. Classification and regression with autokeras for data processing and a pair of fully connected layers for swallowing structured data. If we take a look at TensorBoard analysis, we can see that our accuracy is only 30%, which isn't well. There are also hyperparameters visualized and graphs of nodes showed. Also, from the figure, we can see that for a learning speed of 1, the accuracy reaches 0 very quickly with large losses, which means that we can reject this option because the network is no longer going to learn. Next, here is a part of sample input and output. Studying the model at the operational level gave us an idea how to change it and how to improve it. For example, we can redesign the model if learning progresses more slowly than expected. With all being said, I want to conclude our presentation saying that with the help of the system design tools, we have described the most important functionality of the system. Diagrams of usage, activity, classes, etc. were considered in detail. The analysis of the advantages and competitors was also carried out, and features of our system were allocated. Hope you enjoyed our presentation. Have a good one.